All right, college triggers. Let me go shut off the volume. It's way too loud. So the plan is to get you guys some instruction through videos that I'll either send via email or put on Schoology. I'm not sure which yet. And then have a time for a Zoom session. I believe you guys said you liked the 10 a.m. time slot. Now, that's not mandatory, but if you have a question on the assignment, that's when I'll send out the link at 10 a.m. and you can Zoom in, and we'll try to do problems if you have problems. And then you'll hand in assignments by taking pictures of them and email them to me. And I guess try to make them so I can read them and look at them. When it comes to quizzes or tests, that'll be a little more tricky. I think what I'll do is I'll have you guys. I'll send you the quiz or test via email, and then we'll have a Zoom session where I guess you'll have to sit there and I'll watch you take it, and you can ask me questions. I do kind of like that, but a lot of it will depend on your integrity and what have you of taking it honestly. I think NIAC, as long as we can, show that we have some integrity, and they'll be all right with this format. We're just going to cover 2 sections in Chapter 3. If you remember, right before we left, we took that test, and the only really sections were not included were 3, 4, and 3, 5, which are identities that we're going to look at today. So there really won't be another test on Chapter 3. Maybe I'll give a little quiz over the sum and difference formulas or identities, and then the double angle and half angle identities. And then we'll move into Chapter 4. Chapter 4 is some right triangle stuff, and we'll probably blow through it pretty quickly. It's stuff that you should be pretty comfortable with. I want to keep the pace going because as soon as we cover the material, you're done. And I know it's kind of it's a little goofy. I guess we have time, but it's a little goofy to prolong it if we can just hammer it out, in my opinion. So, all right. So the section today is the 3, 4 sum and difference formulas. Now, they're identities. Now, remember what an identity is. Identity is just an equation where no matter what you plug in for the variable, it's going to be true, okay? And we've looked at trig identities before, and here's a real common Pythagorean identity. I don't care what the angle is. If you take the sine of that angle and square it, and the cosine of the angle and square it, the answer is going to be 1, okay? And so the ones we're looking at are going to be the sum and difference formulas, where you're going to be asked to find exact values, and you've done a lot of exact values. If I ask what's the sine of 60 degrees, exact value, that means exact value means no decimal. You're going to tell me radical 3/2. I mean, we've done those unit circle quizzes before. You're pretty comfortable. But what's going to happen today is they're going to say, well, what's the sine of 75 degrees? The exact value. Well, we really haven't memorized 75 degrees. And so we're going to think of this as the sine of 45 and 30. Now, the first thing I want to make sure you understand is this doesn't mean, it's not like a distributive property. This doesn't mean multiply. It's not like I take the sine of 45, get that answer, take the sine of 30, get that answer, add them together. That's not right. But there is a way to find the exact values using what's called their sum or difference formulas. And in your book, I think I'll slide it under here, under page 210 will be the ones you want to use on this assignment. So when you look at this is, like I said, page 210, there's a pretty nice summary. And the one I was just referring to, I said, well, I wanted to know the sine of 75 degrees. Exactly. No decimal. Well, I don't have it memorized, okay? I do know that I can break it up into 45 and 30. Now, remember, like I said, it's not distribute. But then the sine sum formula says, we'll take the sine of, and then you just follow down the line. Take the sine of 45, take it times the cosine of 30, plus, then you go the other way. Then the cosine of 45 times the sine of 30. And if you get those, make sure you get a common denominator and you add them together, you'll get the exact value. Okay. This, the cosines, cosine, sine. Cosine begins with a C. I always think contrary. If it's a plus in the formula, in the actual, or in the breakup, it's actually a minus there, contrary. Where sine, I think same. If it's a plus there, it's a plus there. But, I mean, that's just my little way of trying to think about it. So these are the sum and difference formulas you'll use again and again. On the assignment for today, and I think what I'll do is I'll just give you the assignment. I'll do a few problems off it. But there'll be ones where it'll say find the exact values, and you'll break it up using one of these. But there'll also be identities where you'll have to use these improving the identity. And remember how identities work. You work on one side to make it look like the other. So without further ado, I think I'll write the assignment up, and then we'll do a few problems off it, and then I'll let you work on it. Like I said, in the future, if you don't know how to do one of them, you can Zoom me at, I think we said 10 o'clock. So the actual assignment, I'll grab my book here, is going to be page 210. Page 210. And you're just going to do multiples of 3, 9, 12, 15, etc. through, I think, 54 is what that says. It'll be multiples of 3. Okay. And like I said, maybe I'll just do a few or one off of each section with you, so maybe you feel comfortable. One thing I noticed, like right away on number 9, it says, okay, find the exact value of sine of 5 pi over 12. To be honest with you, sometimes, especially when they're radians, the hardest part is knowing how you want to break it up. And so not sometimes, probably most of the time for me, I actually think, well, what is this in degrees? And then how could I break it up using common angles? Okay. And so, 180 divided by 12 times 5. Okay, so this is equivalent to a 75-degree angle. Well, I think this is the one I just set up here. If it's a 75-degree angle, I'm going to break it up as 45 and 30, as pi over 4 and pi over 6. Okay. And then it's a matter of kind of going through the formula. Remember, sine is same. Okay. So I'm going to have sine of pi over 4 times cosine of 30, or pi over 6. And sine s is the same, so it was a plus, so this would be a plus. And then it's going to be cosine of 45, or pi over 4, times sine of 30, or pi over 6. Okay. And then, having your stuff memorized is helpful. Sine of 45 is radical 2 over 2. Cosine, or sine of 30 is 1/2, so cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. And sine of 30 is 1/2. And I don't know if you remember from last year, on this assignment, you basically get a lot of the same answers over and over again. Hey, that's the exact value. That's the exact value of the sine of 75 degrees, or 5 pi over 12. Okay? And if you have to, if they want to know what's the sine of 15 degrees, well, that might be the sine of 45 minus the sine of 30, and then you would use a difference, and then you would use a difference formula. Okay, so those are pretty straightforward, I guess. As you come through there, let's see, 9, 12, 15. I'm just looking at your assignment here. 18. So 21 would be one that would be on your assignment. So that was number 9 that we just did. Number 21 is kind of going the opposite way. They're saying find the exact value of each expression, and then they give us this: the sine of 20 degrees times the cosine of 10 degrees. Oops, cosine of 10 degrees, plus, then we've got cosine of 20, sine of 10. Okay, so that's 21. And so if you notice this, I think this is the exact same pattern we just did. Oh, I have a sine cosine plus a cosine sine. I have a sine cosine plus a cosine sine. Oh, what was I doing to those things? Well, it was the sum formula of sine. So you come over here and say, well, this is just expanded out. The sum formula would have been sine of 30. Oh, I know what that is. That's a half. And so that's how you find your exact value. See, 21, 24, 27, 30, 33, I guess might be worth looking at. 33 says there's an A, B, C, and D, which I don't think I'll do all of them, but by doing A, I think I can get you set up. So 33A says find the sine of alpha plus beta, A plus B, okay? Use the sum formula. And then they give us some information. The information they say is the tangent of alpha equals -4/3, and also that this angle alpha is between pi over 2, make sure I'm looking at this right, yeah, pi over 2, it's between pi over 2 and pi, which is basically telling you which quadrant you're in. So actually, you know, the sum formula is not hard. Sine of alpha, cosine beta, plus, and then you reverse it. This is kind of your clue to draw your triangle. We have to be in, let's see, between 90 and 180. We got to be in the second quadrant. And tangent is opposite over adjacent. Now it's negative, so this would be your -3, this would be your 4, and then this is going to turn out to be your 5. Okay? And so when you go to do the formula up here, now the other thing I got to remember, this is that's alpha. They also, so this is for angle alpha. I should write that there. I can't draw an alpha. It kind of looks like a fish. But then they also give us in 33, I didn't read the whole problem, they tell us about beta too. They say, okay, the cosine of beta equals 2 radical 5 over 5, and it is in the first quadrant. It's between 0 and 90. Okay, and so if this was my alpha angle, my beta angle's over here. And so, you know, I think, well, cosine's adjacent over hypotenuse, so I could say, well, the adjacent is 2 radical 5. The hypotenuse is 5, and I could do the Pythagorean theorem in reverse to figure that out, which I suppose I'll have to do here. This squared, 2 squared is 4, 4 times 5, so that's 20, plus missing leg squared equals 25. So this is going to be radical 5 is what that's going to be if I'm doing my math right there. 5 squared is 25. Be 4 times 5 would be 20. Yeah, so what? Yeah, it has to be square root of 5. But anyway, now that you know that triangle, when it comes time to do this up here, which says, you know, the sine of alpha, cosine of beta, sine begins with an S means same, and then you reverse it, you can get these values by looking at the triangles you just drew. Oh yeah, alpha will come off of this. Oh yeah, cosine and beta will come off of this, and you can plug in the values. So that's kind of your lesson for 3-4. I think while I'm at it, I'll just keep going, and I'll put the assignment, if I can find some scrap paper here, I'll put the assignment for 3-5 up, which is half angle, double angle stuff. And once again, it's just identities. The thing that makes the double angle identities a little harder is there's several of them. So what I mean by that is, let's see if I can find what I'm looking for here. So like here's your double angle formulas. This is on page 213. You can see there's one listed for sine. The sine of a double angle is this, okay? But for cosine, there's three other ones that are equivalent. The cosine of a double angle is always the same as that. The cosine of a double angle is. So if you're doing an identity problem where you're trying to move, prove one side looks like the other, and they have the cosine of 2 theta in there, any one of these can plug in there. I mean, you kind of have to look and see which one you want to use. Okay? And so, and then there's half angle formulas, which are, they're on page 217. People ask, well, do I have to memorize all this? Like, the double angle and half angle formulas, I would say no. The sum difference formulas, other than the tangent ones, are pretty straightforward. I mean, it'd probably be an honor system, and I'd have to ask what the NIAC people are doing. But to me, I'm less concerned about you memorizing it, I guess, as I am you're able to find it and use it correctly, in my opinion. Okay, so I'm gonna give you the assignment for this next section, the section 3.5 as well. And like I did in the last one, I think what I'll just do is do a few problems off it, and then if you guys have questions, we can Zoom at 10 o'clock. Probably not, I don't know by Monday if you'll have this yet, or by Tuesday, if you have questions on these assignments, and then you'll just take pictures and send them to me. And we'll get you your credit, and the world will be a beautiful place. All right, so the 3.5 double angle, half angle stuff. The assignment's going to be page 219, and it's going to be 9 through 27, multiples of 3, and then I think 50 through 65, we'll go multiples of 5. Okay. All right. So, I guess we can just look at number 9. So what they're going to give you is kind of like the last, it's a lot like the last assignment. They're going to say, hey, the tangent of some angle is 4/3. And then they're going to tell you that angle falls between, it's larger than pi, and it's less than 270 or 3 pi over 2. And really all that's doing is kind of giving you an opportunity to draw. Okay, I'm in the third quadrant. I know tangent's opposite over adjacent, and they're both negative. That's why the tangent's positive. You can do the Pythagorean theorem and find out that's going to be a 5. Now what they ask you to do here is, okay, sine of 2 theta. Remember this right here is theta. Okay, well, it's a double angle formula for sine. You go back, you look up the double angle formula for sine, and you see the double angle for sine is simply this, 2 times the sine of theta, cosine of theta. Well, I have all that stuff. 2 times the sine of theta, sine would be negative 4/5, times the cosine of theta. Well, that'd be negative 3/5. And so you work it out. It's going to be positive. What do we got? 8 times 3 is 24/25. Okay. And then they want you to, do that. I think it says there's an A, B, C, D where you're doing it for the cosine and the sine half angle and the cosine half angle. So draw your pictures, find out that you're in the right quadrant, follow the formula, plug and chug, away you go. Okay. Now let's see, on 12, 15, 18, 15, 18, 21. Okay, I guess we could look at 21 there. That's a new section. So 21, it says, use the half angle formulas to find the exact value of each expression. And it's tangent of 7 pi over 8. Okay. And so you might say, well, and it says use a half angle. Oops, sorry, you can't see that. And it says use a half angle formula to give me the exact value for that. You might say, well, how do you do that? Well, I guess maybe what I would let you know is, like if number 19 wasn't assigned, but it might be helpful in just looking at it. It says the sine, if I can give me the exact value of the sine of 22.5 degrees. Well, I don't know what the sine of 22.5 degrees, but I know that the sine, and if I took half of 45, that would be 22.5, and I know there's a half angle formula for sine. Now, we didn't cover these last year, okay? So they might not be as fresh in your mind, but if you look, I'll just put it up here. If you look right here, oh yeah. If I think of that as 45 over 2 is 22.5. And so if I want to know the exact value, it's going to be 1 minus the cosine of 45 divided by 2, square it, plus or minus it. Okay? So, with that being said, there's also one for tangent. I'll put it up here. Okay? This, by the way, is on page 217. Oh yeah, tangent. If I had something and divided it by 2, and that's what I was looking at, I would use this. So now, once again, kind of like I said the other time, sometimes the hardest part is figuring, well, what am I taking half of? Well, if I want to know the tangent of 7 pi over 8, that's really tangent of 1/2 times 7 pi over 4. And that's what 7 pi over 8 is. Okay. Now you might say, well, I didn't memorize anything about 7 pi over 4, but that's a common angle. Okay, that's 45 degrees. So, 7 pi over 4 would be all the way in this quadrant right here. 45-degree reference angle. Okay, well, that's pretty easy. The tangent of 45 degrees is 1, and this quadrant is negative. So, what I'm going to do is I'm going to go to the tangent. I'll just write it out for you. The half angle formula for tangent is plus or minus square root of 1 minus the cosine. Now, like I said, it's 7 pi over 4, which looks a little intimidating, but that's just 45 degrees in that quadrant. You guys got to remember that. Over 1 plus the cosine of 7 pi over 4. Well, 1 minus, like we said, the cosine of 7 pi over 4 in that quadrant is positive 1. Okay, positive 1. And then 1 plus, well, you're going to get 0 over 2. It looks like the answer is going to be 0. Okay, tangent of 7 pi over 8, which doesn't seem right in my mind, but hopefully it is. So, but yeah, it's really kind of a plug and chug section as well. We'll have time to zoom if there's ones that don't work out. Probably the more interesting ones will be when you get to some of the identities. You have to plug in those double angles, half angle formulas to make the identities work out. So, all right, long enough video. I hope you're enjoying your time at home. I don't know if that's the right thing to say, but I think it's probably the right thing we're doing. One of these days I want to make a video, and this sounds morbid, but get out Desmos, plug in the death numbers, maybe worldwide or maybe just United States, and run a logistics regression and really see how close we would be to predicting where this thing's going to flatten off and what actually happens. So tons of math and science involved. Not going to happen on this episode, though. Have a good day. Bye.